Hi guys, today we're going to do Unit 1, Section 8, percent of change. Now there's a lot of different ways to do this, but because we just finished talking about proportions and how to set up proportions, that's what we're going to do here. We're going to use proportions to solve this. That's not saying there isn't another way to do it. There is, but that's what we're going to work on right now. Okay, so there's a formula that we like to use in Algebra 1, and I think that some of you have seen it in middle school. It's n minus o, no, over o equals percent over 100. N stands for new, O stands for original or old, percent just stands for your percent, and 100 is always going to be 100. Okay, so we're just going to use this, and then we're going to solve like we would do any other proportion. Okay, so let's get to the examples. Example 1. So let's say the original price of whatever you're buying is $25. And the new price, so what, I don't know if you remember back in elementary school, some of you did Ameritown, and you found out that if you could sell something and it was going really quick, that you could actually maybe up the price. So that's what happened here. They found out the original price is $25, and they said, well, it's selling really fast, maybe we can make more. So they put it up to $28. The question is, what is the percent of change? Anytime you see percent of change, you can use this proportion. We call it no O. Okay? So I'm going to rewrite the formula so I remember what I'm doing. No O equals percent over 100. So now we have to decide which. Well, in this case, it's pretty simple because the original price is marked that. So that's my O. And the new price is marked new. And so that's my new. Okay? So I'm going to put in my new price of $28. I'm going to subtract the original or the old price of $25. And that $25 also goes in the denominator. Don't forget those parentheses. That's going to be important. So I'm going to put those parentheses that were originally in the formula. And on the other side, there's the 100. The only thing we don't have is the percent, and that's what we're looking for. So that's where I'm going to put my X. Okay? So now we have a fraction equal to a fraction, which means we can use the cross product, or we can cross multiply. So we're going to cross multiply here, and that's going to give us 25x. And over here, we're going to go 100 parenthesis times the quantity 28 minus 25. Now here's the deal. A lot of people want to distribute that 100, and you can do that. There's nothing wrong with that mathematically. But to make this simpler, we can first look inside the parentheses and see that can be simplified. So 28 minus 25 is 3. So now we have 25x equals 100 times 3. Well, 3 times 100 is 300. Back to a one-step equation. What's going on between the 25 and the x? It's multiplication. So we have to use the opposite operation. What's opposite of multiplication? Division. So I'm going to divide both sides by 25. And x is going to equal 12. And we were talking about a percent of change. It's a positive percent of change. It's going up. It's an increase because we increased the price. So it's a positive 12%. Okay, let's go to another one. The original price is going to be $25 again, but the new price this time is $10. This could be a couple reasons. Maybe they decided to put it on sale. Maybe it's the end of the season. They want to get rid of things. There's a different maybe nobody wanted it, so they're just trying to make whatever money they can from it. So let's go back to our formula. No O equals percent over 100. And let's fill in what we know. We know the new cost is $10. The original cost is $25. Don't forget those parentheses. That's important. And the original is $25. So be very careful of that. 100 is always going to be there because we're talking about a percent. And again, we're looking for the percent of change. So I'm going to put an X there. Okay, this time we went from a high price to a low price. So I want you to pause and think about, what does that mean for our percentage? Let's cross multiply and see what happens. So we get 25x equals 100 times the quantity 10 minus 25. Now again, you could distribute the 100 and then subtract. I prefer to subtract inside the parentheses and take care of that. Now some of you have a hard time with negatives and positives, so you need to check your work using a calculator. 10 minus 25 is going to be negative 15. Do you see what's happening yet? If you weren't sure about it before, what do you think the percent change is going to look like? So that's going to give us 100 times negative 15 is going to be negative 1,500 equals 25x. And again, what's going on between the 25 and the x is multiplication. Opposite operation, and we got to do it to both sides of the equation. And when we do this, now I actually used a calculator. I did negative 1,500 divided by 25, and you would get negative 60%. Stop and think about it. Why is that a negative? It's because the price went down. So we lost 60% of the original value. It's down 60%. It is a decrease. Now, they could give you something different. So let's look at another example. They could give you the original price of $45 this time, and they could tell you what the percent of change is. In this case, I'm going to say the tax is 5.5%. Now, you have to stop and think before you do your formula. If we're adding a tax, is the price going to go up or is it going to go down? If you know anything about taxes, that means $45 is not what you're actually going to pay. You got to add 5.5% to that. So I am going to put a big plus sign in front of this to remind myself this is an increase in percent, so it has to be positive. Let's use our formula. No O equals percent over 100. Now this is where we got to be careful. Do we know what the new price is? We don't. We know it's going to be more than $45 because we're adding tax to it, but we don't know exactly what it is. So in this case, the N is our variable, our unknown. It's what we're looking for. The O, the original price was $45, which was given to us. Don't forget that goes in two places. This time we keep the 100 as always. And this time we were told the percent of change, and it was positive 5.5. Now the reason we can leave it as 5.5 is because it's already over 100. So we don't have to change that. We already have the 1 per 100 right there. Okay, now this is going to take a little more algebra. We're going to cross multiply and we're going to solve this. So the first thing I'm going to do is cross 45 times 5.5. Now you'll notice here I did not use a dot for multiplication, and there's a reason for that. Do you know what the reason is? It's because we have a decimal there, and to put another dot there might get confused with that decimal. So instead I put them both in parentheses indicating multiplication. Okay, then we got to multiply that 100 times the quantity, don't forget those parentheses, n minus 45. So this one's a little different when we go to solve. Let's first look at the left side and see what we can do with the left side. So 45 times 5.5 Let's figure out what that is. That's going to be 247.5. What can we do on the right side to simplify? Well, we can distribute. We already learned this in the other chapters. If you're having a hard time, I would say go back and watch those again. 100 times n, so that would be 100n, minus 4,500. Watch your zeros here. Now this is a two-step equation. We always want to deal with the add subtract first. We want to figure out what we can move first. So we're going to add 4,500 to both sides of this equation. N needs to get by itself, so that's what I'm going to do. So that gives us 4,747.5 on the left side, and we still have 100n on the right side. The negative 4,500 was canceled with the positive 4,500. That's why we did that. We're going to divide both sides by 100, and I got 47.475. Now, if you write that on the line as your answer, I'm going to take a point away, and I want you to stop and think about why. We are talking about money here, and so this needs to be rounded to the nearest cent unless we tell you otherwise. If you're dealing with a real-life problem and we're dealing with money, you round to the nearest cent. 5 rounds up, so this will be 47.48. That's our new price. Now, before we move on, let's make sure that makes sense. We were originally paying $45. We had to add a tax to that. It was only 5.5%. So does $47.48 make sense when we're talking about tax? And it does. If you got $474.86, then maybe you need to stop and think, because if you're paying that much on a $45 item, somebody's getting ripped off, and it's most likely you. So be careful that these are making sense when you do them. Let's do two more examples. This one's a little longer, I'm sorry. So this one is, let's say, this is example 4. In example 4, let's say I give you the original price, and this is let's say I'm in Kohl's, and it's $95, and I have one of those coupon deals, and it's going to be discounted 25%. Now be very careful here. If it is a discount, that means we're going down in price. We have to show that somehow, and that has to go in front of the percent. So we're actually subtracting 25% from the original price. So the discount is negative 25% because the price is going to go down. So let's look at our formula as we did before. And so parenthesis, no minus O, all over O equals percent over 100. And let's see what we know here. We do not know the new price. We want to know what the price is going to be after we take away 25%. So the N is going to stay. The original price is $95. We're going to put $95 in the original position. Now this is where you got to be careful. It's negative 25 here. And of course the 100 always stays. We're going to cross multiply. So 95 times negative 25 equals 100 times the quantity, which means put parentheses, n minus 95. And from there now it's just a multi-step equation. So if we multiply negative 25 times 95, we get negative, now be careful, watch your negatives, 2,375. And over here we can distribute that 100, get 100n minus 9,500. Now we need to add 9,500 to both sides. That's going to leave us with 7,125 equals 100n. Divide both sides by 100. And the new discounted price is $71.25. Now I'm going to check it. Does that make sense? If the original cost was $95 and now I took away 25%, does it make sense that it's around $71? That makes sense. If it was more than $95, then that tells me I forgot to put the negative on my percent. So that's that one. We're going to do one more. Okay, now this one is kind of a multi-step problem. So if I tell you, I think we're on example 5. The original cost is $545. This is going to be taxed at 22.5%, but it has a discount of 30%. This is actually a two-part problem in one. Isn't that exciting? You get to do two problems instead of just one. So I always start with the discount. So I'm going to start with the discount part of the problem. Now again, it's a discount. So is that going to be a negative or a positive percent? It's going to be negative because we're taking away money. Here's our no O over O equals percent over 100. We don't know the new cost. I'm only dealing with the discount right now, okay? So I'm just going to deal with the discount. So I'm going to take the original, which is 545, and put that wherever the O's are. And I'm just going to deal with the discount, so I'm going to put negative 30 over 100. Now I'm going to do the arithmetic. I'm going to do the algebra. I'm going to cross multiply. So negative 30 times 545 equals 100 times the quantity n minus 445. Let's simplify each side of the equation. So on the left side, we'll have negative 16,350. I did use a calculator for that. On the right side, I'm going to distribute that 100. So I have 100n minus 54,500. Now it's a two-step equation, so I'm going to add 54,500 to both sides, being very careful that I check my work to make sure, because I have negatives and positives going on here, so you might need to check your work with a calculator. I get 38,150 equals 100n. Divide by both sides by 100. And now our discounted price is $381. I'm going to check to see if that makes sense. Well, the original price was $545. It's a discount of 30%, and so we're down to $381. But that's not what's going to be rung up when you go to buy this, because we still haven't figured out how much we pay in tax. So now I'm going to say the original price before tax is going to be $381. The tax that I told you from above is 2.5%. Now remember, if we're dealing with tax, we're dealing with adding to it. So our tax, our percent change, is a plus 2.5%. Now we set it up just like before. N minus 381. You can put the 0.00 if you want. Oh, it's 50. Sorry, I couldn't read my own writing. This is 50 cents here. I thought that came out too nice. So this is 50 here. So let's go back and change this to 50 cents. And then this to 50 cents. Okay. All right. So N over original price, $381.50, equals, this time it's a positive 2.5 over 100. I'm actually going to stop there. I'm going to tell you can finish this out, but I'm going to tell you the final answer. The final price, after adding everything in, doing the discount, if you do this correctly, is going to be $391.04. So see if you can go from here to here and do the steps and get the right answers.